Very good morning, students. Welcome back. Today we'll continue the remaining part of Module 4, that is optimization goals and figures of merit. So last class we discussed about the different network scenario of wireless sensor network, and today we'll discuss the different optimization goals, figures of merit. So as you know, for different network scenarios and application types, different form of networking solutions can be found, because we are not fixing any networking solution for the applications. So as application varies, we have different networking solutions also. So in this way, we have a lot of challenging question, like how to optimize a network, how to compare these solutions, how to decide which approach better support given applications, how to turn goals into a measurable figure of merit. So this is very important. So this is fixed question in almost all exam point of view. Optimization goals, explain optimization goals and figures of merit. So we listed some four important optimization goals for WSN. Optimization goals is also count into measurable figures of merit. Okay, so we have quality of service, very important, energy efficiency, scalability, robustness. Let's start with the first optimization goal, that is quality of service. We know in MANET there are different QoS, quality of service interpretation, that is throughput, delay, jitter. They all these count in order to decide the quality of service, even some high perceived QoS for multimedia applications. Whereas in the WSN, more complicated. For example, we have to decide event detection reporting probability. So whether the network or node is detected correct event or not, and that should be reported to correct sync or not, and event classification error. So whether that node is detected correct event, and that is left to the respective classification, because we know different events are exist in the network. So detection delay is also comes into count. So probability of missing a periodic report. See what happens, suppose if we in our system, if we are doing a periodic report, okay, so if any missing data, that will lead to a very big problem. Then approximation accuracy. So when WSN constructs a temperature map, so you should know the location. So for different location we have the different temperature measurement. So that's why we need to know approximation accuracy and tracking accuracy. Once one should know the location of the respective node. And related goals for robustness is network should withstand failure of some nodes. Okay, so all these are quality of service. Okay, so majorly depends on how much accurately the node will detect and send a report, and a delay of all these event which is occurred in the nature. Okay, so all these will count. So this is nothing but the quality of service. Second optimization goals or figure of merit is energy efficiency. Okay, so when you are handling the WSN, the first thing comes in your mind is that energy. What best, how best, and energy should be effectively, efficiently used or utilized by the node. So we have to see energy per correctly received good, counting all the overheads, energy per reported event. Okay, so whether it is correct or not, after all, information is important. Typical for WSN. Okay, delay energy trade-offs. Once we should know delay also. So if it takes more delay, so more power or energy is consumed. So all these will count, especially in order to measure, in order to calculate the network lifetime. So network lifetime depends on these following parameters: time to first node failure. Okay, so network half-life. Half-life is nothing but how long until 50% of the nodes died. Time to partition, time to loss of coverage, time to failure of first event notification. See, all these will count when you handle the WSN. So all these comes in energy efficiency optimization. The last one is scalability. So scalability is totally belongs to the how many number of node comes inside the network or goes away from the network. So okay, because we cannot predict and expect the movement of the node in the sensor network. Okay, so that is very very important. So network should be operational regardless of number of nodes. Scalability, because very high dense of nodes are there in the wireless sensor network. Okay, so we should know. Then typical node number should difficult to guess. Manet 10 second to 100 second. Then WSN, see maybe more, even 100 to 1000 seconds. Okay, so it's a number of difficult to guess, requiring to scale to large node numbers. Okay, so all these will count when you talking about the wireless sensor network. Scalability, so scalability, you should know the movement of the node, whether it is going away from the network. So all these will count when you are measuring performance of the network. So definitely it will affect. That's why this is one of the optimization goals, scalability. Okay, for the WSN. Then yes, very very important thing is design principle for WSN. As we know, we have different design principle for IoT, because we studied IoT in module 1 2 3. The same thing we have to look for design principles for WSN. So these are following points which will decide the principle for WSN. So I will just read out: distributed organization, in network processing, adaptive fidelity and accuracy, data centric, exploit location information, exploit activity patterns, exploit heterogeneity, component based protocol stacks, and cross layer optimization. So first one is distributed organization. Both the scalability and robustness optimization goal, and to some degree also the other goals, are very very important for WSN. That means there is no uh, self, or there is no centralized entity in charge. Such an entity could be an example. So there is no centralized system for this distributed organization, because the node, it is given freedom to each node that they have to configure, they have to collect the data on their own. So we have, the best example is self organization. So self organization is belongs to the distributed organization. So this is the example. In networking processing, in the sense, we have to look how they will calculate, compute, capture all those things. So best example is aggregation. So aggregation, what happens, especially in the in network, when organizing network is distributed fashion, the nodes in the network are not only passing on packets, execution application program, they are also actively involved in other decisions also. So this is called aggregation. So especially in wireless sensor network, the node which is acting as a source, so many nodes, neighbor nodes will send the information to the source node, and in turn source node will send the information to the sink node or destination node. This is what we call it as a aggregation. So it may be distributed, it may be distributed and collaborative signal processing, then mobile agent based networking or mobile code networking. All these count for this in network processing. The third one is adaptive fidelity and accuracy. Of course, it should be hand fidelity. Fidelity in the sense accurate. So hi-fi is nothing but Wi-Fi. So wireless fidelity. All these are example for fidelity, means it should be perfect, adaptive. So it should be adjustment in nature, and accuracy. So it should be perfect. It should be accurate. Okay, so that is also there. Then data centric. Of course, WSN is the data centric, not the node centric. Okay, so because we are very much depends on the data which are collected by the different nodes, how they collect the data, how they process the data, how they communicate to the sync node. So all these, so WSN is not at all node centric, it is a data centric. Then exploit location information. So exploit location information in the sense it is also another useful technique for getting the information or location of the node. Okay, so that is exploit location information. Then exploit activity patterns. So activity patterns in a WSN tend to be quite different from traditional network. Okay, so we should know data rate. So activity means how fast it will send, how fast it will receive. All these things will comes under exploit activity pattern. Then exploit heterogeneity. So this is very important. Heterogeneity means the nodes are not same. So many nodes are present in the WSN. So all these are not same. So heterogeneity means they may different in the uh, with batteries, battery power. They may different in the communication device. They may depends in the processing power. They may different in the computing power. So they have the heterogeneity in nature. So all nodes will not be same. So this is how we can calculate. And again, some nodes may use same data rate, some nodes may use different data rates. All these are very important. So that's why it has to exploit the heterogeneity. Then last one is component based protocol stacks and cross layer optimization. So this is also very important. So one should look, the protocol components will also interact with each other in essentially different types. Okay, so component based protocol stacks. So how which component will communicate with the other component of the nodes. So all these will count. So this is the very important concept of WSN design principle. So all these 8 principles are very important for wireless sensor network. In the next class we'll see gateways, how gateways will designed and operated. Thank you.